Welcome to CXOTalk episode 853. I'm Michael Krigsman, and we are discussing Agentic AI with agents and intelligent workflows. Our guest is Praveen Akkiraju, an entrepreneur and venture capitalist investor with the VC firm Insight Partners.
I'm a managing director at Insight Partners. Insight Partners is a growth stage venture firm. We've been around for 25 years, about 49 billion invested in about 800 plus companies. I spent many years of my early career running engineering teams and product management teams. At Insight, I primarily focus on deep tech, based in the San Francisco Bay Area, primarily developer ecosystems, cybersecurity, and obviously automation and AI.
That term agentic, I find really weird. It's like, what is, what is it? What is agentic AI? And give us a background of AI as it relates to this, and why has agentic AI suddenly erupted in popularity recently?
It might be worthwhile for us to just spend a minute just looking at the state of play in AI. I'm sure as a lot of your listeners probably realize, we are in profound change. And, it almost seems like every day there is a significant step forward in our capabilities with AI. Just over the last few days, we've had a model that's a significant step forward in reasoning that was launched from OpenAI, the O1 model. You've had Google launch a new model which is significantly more performant and more importantly, 50% cheaper. We just had a multi-model open source model from Llama that just came out at 3.2. So we are in this sort of profound stage of rapid development. If I take a minute and just kind of go back, right? I was, I started my career in the early phases of the internet, and the internet was an equally profound technology platform shift because life essentially moved online, right, with the advent of the internet. And AI, I think it's sort of a similar stage of evolution where we're sort of in the early stages of having the infrastructure being laid out today. So lots of advancements in models and algorithms, as we just talked about, significant advancement in terms of how we're thinking about data, which is a key driver to continuing to advance the state of quality of AI. We've all talked, we've all read the news in terms of nuclear power plants being restarted, right? And in order for us to be able to support these massive compute farms and data centers that will be required for AI. So we're sort of in that rapid stage of infrastructure build out, even as we sort of explore applications of AI like agents and co-pilots and assistants.
When we talk about agentic AI and agents, intelligent tasks, intelligent workflows, what actually are we discussing? What are we talking about?
The first instantiation of AI agents was actually started with the release of two open source projects, AutoGen and Baby AGI, back in March of 2023. Yohei Nakajima, I would say one of the pioneers in the space of AI agents, essentially launched his open source project, Baby AGI, in March 23, with a very simple focus on automating simple tasks. He was essentially a project that said like, hey, I've got these repetitive tasks I'm doing. I'd like to be able to automate them. Can I use generative AI as a means to do it? So that was really the first real instance of an AI agent. And the focus really was, how do you automate tasks in a more intelligent fashion? Now, we've been doing automation for a long time, right? We've had RPA, technologies like that are widely deployed today. But I think what was different about this aspect of automation is that the dynamicity, the ability for the agent to be able to dynamically adapt to the input from the user as well as the environments that it's working in, is really what defined, if you will, that next phase of automation. So from a purely technical perspective, agents are defined as an application or a function that can essentially execute tasks autonomously. So that's the proper technical definition of an agent. Now, in the market today, you see a number of agents. I mean, it's hard to, I think they even showed up on San Francisco billboards, right? Which essentially shows you that the vernacular has been widely adopted. However, I would say that we're sort of in the early phases of this journey towards a truly sort of agentic, architecture in the enterprise.
We're all very experienced with horrible chatbots that for various enterprise software companies sell as this is great customer experience. And we all know that it's not great customer experience. It's terrible. So how is this different from that?
You have to think of this as a continuum, right? So chatbots were sort of the early instantiation of using, a basic sort of machine learning model or even a data model to essentially be able to respond to questions with, accessing a library of data, right? Where I think we've seen significant developments, right, and continue to see significant developments is in the space of copilots, right? So a copilot essentially, you can think of it as a generative AI model that's able to do work by itself with human guidance. So a good example of this, for example, would be a coding assistant or a coding copilot. So we made significant progress in coding copilots. I think the Claude Sonnet 3.5 is one that I've personally played with. And you have this really amazing feature called artifacts. So you want to kick off a coding project. You have the ability to basically understand sort of what the AI is actually doing in terms of the specific steps, go in there, edit those steps, right, and be able to then have it execute by itself. So effectively think of it as an assistant that's enhancing the ability for a human worker, engineer, depending on the use case, to get through repetitive tasks and execute tasks faster with human in the loop. The promise of agents is that you trust AI enough that it's able to autonomously take a task, break it down into a specific set of steps, and then execute those steps, and then give you the result, right? It's also been very, I find this analogy pretty interesting, is today we are in the stage of sort of a competent intern, right? You have an intern, you're able to give that intern a certain set of tasks. They come back to you and say like, hey, this is what I'm doing. Does this make sense? Yes, great. Where agents would be is like a competent colleague, effectively a colleague who is able to, given a task, execute a set of tasks, and maybe you sync up with them once in a while, right? And you treat them and you trust them to do the task given to them, effectively, right? So I hope that kind of helps you, gives you kind of a broad set of the spectrum of where we are from chatbots to copilots to agents, right? And I would say again that we're sort of in the early part of that journey towards agents because we still haven't truly figured out how to make them fully autonomous.
When we talk about autonomous, can you elaborate on that? Because I think to some degree, it's that term that separates agentic AI from traditional chatbots. And we think that there's a lot of magic in that term autonomous.
Let me kind of maybe break down what an agent looks like, right? So if you were to actually like open up an agent. So what's inside the box? The first aspect of an agent is essentially a user interface. Think of it as like essentially your a box where you would type in your instructions. So it's behind that essentially is a natural language processing capability, which is able to understand the intent of the user, interpret the text, and then be able to feed the model to say, okay, this is essentially what the user is stating, right, or is asking to execute. So the next step down, once you sort of put in your task and you're able to interpret it, the next step is what's really the most important thing in an agent, which is a planning or a reasoning function. So you have stated task. Now, can you take that task and be able to sort of create this sort of plan, if you will, how to execute the task. So let me give you a human analogy. Let's say you were, you want to basically travel to San Francisco. you would in your mind, you'd say, okay, I've traveled to San Francisco. I need to figure out which date I want to go, which airline, what kind of fare do I want, et cetera, et cetera. And then you create a set of steps, and then you go execute. Okay, I'll go to the airline website, book my tickets, right? Get an Uber to go to the airport, et cetera. And so that's what a human mind essentially does. So the aspect of an agent that makes it autonomous is essentially this reasoning and planning capability. And that's why it was so exciting to see what the GPT-4o1 model that was recently announced, because it's a significant step forward in advancing the capabilities of generative AI to do planning and reasoning. Now, we're not fully there yet, but it's a significant step forward. Now, once you plan the task, right, you need to you now have a set of things that you're executing. So you need to be able to have access to a set of tools, set of integrations, if you will. So being able to call up another model, or being able to access the internet to get some data. Again, going back to the airline example, you might need to launch an API to go search the web and say, what are the best flights available to San Francisco, right? So tool calling or API integrations is another critical part of an agentic workflow. So once you do all of these things, let's say, so you understood the intent, you've planned the task, you've collected the information, and you've executed some code, whether it's static code or other models. Now you have the output. What typically good models do is they send it to a reflection loop, which effectively tests the output to make sure that it is as close to accurate as possible. And this becomes more important in mission critical tasks, right? So you have a model that's trained on ideal output. So you compare the output with the ideal output, and if required, you send it back through the agent in order for you to get a refined answer. Then maybe you send it through a governance function, because let's say you're an HR function, you don't want anybody to be able to, pull up somebody else's salary, right? So there's like a governance policy function that you might send it to before the output is actually given to the user. So that's really the way I would break down an agent: a user interface, a planning reasoning function, tool calling, integrations, a reflection loop, policy and governance, right, before the output comes out. So if you think about that as the composition of an agent, you can clearly see like there are many aspects, many moving parts here that you need to compose, right? And so this is where most of the cutting edge developers of agents are really focusing on, because some of these are hard problems. Some of these obviously are solved problems. You can call APIs anytime. And there's various aspects to this that are it's actually an engineering integration problem and less of an AI problem if you think about it.
Subscribe to our newsletter. Go to CXOTalk.com. We have great shows coming up. The crucial aspect here that distinguishes agents from other types of computer science problems or applications is that reasoning step. Is that correct?
Absolutely. I would almost say that planning and reasoning is the barrier that generative AI needs to break through in order for us to truly unlock the agentic future, right? So if you maybe spend a minute on the latest model that was announced, GPT-4o1, what they've essentially done is they've incorporated this concept of chain of thought reasoning. So, if you go back, one of the techniques of prompting that's advocated is to give the model a chain of thought, essentially, guide it through each and every step of the process by asking it questions and asking it to reflect on the answers of those questions. So what O1 did was to take that chain of thought prompting process and absorb it into the model itself. So it takes a little bit longer than your average, GPT-4o model to execute. It's essentially thinking on every step. And so that is essentially the way we're approaching this concept of planning and reasoning. Another technique that Google recently announced was this notion of self-correcting on reinforcement learning, right? It's another technique that they've incorporated into their models as a way, it's similar to chain of thought reasoning, which is to force the model to think about its output at every step and make sure that it is self-correcting itself based on and learning from that process, right? So all of these are ways for us to be able to kind of break through that planning, reasoning barrier, if you will, which is the true unlock.
We have a very interesting question on LinkedIn from Michelle Clark, who makes 2 points. Number one, she says, can we call these AI agents instead of trying to make up a new word?
AI agents is is an established industry term. I think you see that in the vernacular. I think even, Salesforce recently announced Agent Force, so it's here to stay, right? Maybe it's the term of 2024, just like Copilots was the term of 2023. But it captures, as I said, the essence of what we expect from AI in a practical application.
But Michelle's real question is this. She says, what percentage of agentic work is focused on enterprise back office processes? And she says, it seems that's much more fruitful than front-end human interaction tasks. So 2 different questions.
You will see, I think, agents proliferate across the spectrum from consumer all the way into the enterprise. So if you double click on the enterprise set of use cases, what is the promise of AI? The promise of AI is essentially productivity gains, right? So how do you get productivity gains? By essentially automating these back office tasks, as Michelle rightly pointed out, in a more efficient way. Now, just to be clear, like we're doing some of that today, right? When you think about RPA and what RPA does, it has done a phenomenal job of taking manual, repetitive tasks and automating them, right? And created a ton of value in the enterprise. Now, however, it has not been able to break through that barrier of dynamicity, right? And being able to sort of adapt or being able to sort of on the fly figure out what the user intent is and be able to automate things. So a lot of what automation really comes down to is this notion of integration, right? So the first step, as any CXO, any of your audience will tell you, is really you got to get your data infrastructure in shape before you even start this journey around AI. So once you get that in shape, what is really backend is like extracting data, comparing data, right? Being able to sort of create, a model or a report that a human analyst typically looks at, right? And so if you're able to kind of automate a lot of that I think can unlock significant amount of value and gains.
This is from Chris Peterson. It's a technology question. And he says, in the current generation, are the agentic AI layers all based on neural networks or LLM models? Or are some of them more traditional symbolic AI kinds of code?
If you decompose the agent, right? The steps that we talked about. So there's a user interface. That's clearly a large language model or a natural language processing model, because what you're doing is you're interpreting language, right? You're interpreting text. It could be an image, etc. in the future. The second layer is planning, reasoning. This again is primarily built on a large language model because there's a dynamicity to it. In the previous sort of era of machine learning, like a lot of predictive and reinforcement learning models, those effectively were able to recognize patterns. Right here, you're reproducing patterns. So I think that's a fundamental difference between, I guess, what we knew as the pre-generative AI, if you will. Now, once you kind of you're able to break down these tasks. Now, the tasks that actually execute. It could be essentially an old school reinforcement learning model. It could be a predictive model, could be a forecasting model, right? Which don't need to be generative, obviously, right? A lot of your audience and enterprises have deployed predictive reinforcement, forecasting models, fraud detection models. They're in production today at scale. So we're not reinventing the wheel here, right? We reuse what works, which is if you have static code, like if you have a set of logic, like code logic that's part of your application, you reuse that, right? If you have a forecasting model, you reuse that. And if you do need a large language model, right, for a task that the agent is determined it needs to do, like maybe you're writing some code or something like that, then you use a generative AI model. So I think, look, as I mentioned, like I've sort of been through a couple of these technology transitions. For me, generative AI is a tool, and engineers and builders, right, and sort of CXOs should view it as such, right? Use it where it makes sense, and just use good old school reinforcement learning or existing machine learning models or static code where it makes sense.
So your point is you use the appropriate tool, that what matters, it's not the tool or the technology, but rather what's the outcome you're trying to achieve, and will that tool get you where you need to go?
Right. Yeah. I mean, there's a engineering principle we used to use, right? Keep it simple and stupid. And so that effectively means that just because you have something really cool in terms of a large language model doesn't mean that you need to use it, right? You have to think carefully about the outcome, the use case.
We have a very interesting question from Arsalan Khan, and this is a social cultural question, not a technology question. And he says this: what is the ultimate goal of these agents? Is it to replace people? Should employees train these agents so that they won't have a job anymore?
There's a spectrum here in the sense that there are clearly certain types of jobs that, where it's, just repetitive work that is part of every productive workers, knowledge workers kind of milieu that can be automated and should be automated, right? There was a time when, opening a bank account means that somebody was actually logging that, bank account in a register and keeping track of accounts manually, right? And, we went to spreadsheets, and then we went to computers and effectively, scaled, right, the ability to open an account instantaneously and offer a better service, right? So I do think there'll be a category of jobs which are repetitive, which are non-value add in the overall scheme of things, background work, back office work, as one of your audience members had earlier stated, that absolutely need to be automated and can be automated in a more elegant way with generative AI or AI agents, if you will. I think the future that people ascribe to AI agents is like all of us have our individual AI agent, right? Michael, you might have one, I might have one, and our agents might communicate with each other and set up our meeting, right? So is that really, those things make us more efficient, not necessarily kind of replace a particular function. But I do think it's a fair question to ask because, and I will say that we're still in the early days of AI to really explore what this technology truly can do. On one end of the spectrum, you have a lot of sort of like, hey, it's going to take our jobs, it's going to replace a bunch of people, and it probably will in terms of, again, manual, repetitive tasks. If you're a customer support agent answering like, I lost my password questions, yeah, that job's probably going away, right? But if you're an engineer, or if you're, a financial analyst, or if you're a marketing, expert, right? This could dramatically amplify the productivity, quality of your work, right? And I think that's the way we currently view it. Now, there's this notion of AGI and what happens when what comes about. Is it 1,000 days away, as Sam Altman mentions, or is it a few years away, as some of the other researchers mention? It's TBD. But technology is a tool, and I think humans have over the years, I guess over our over our entire existence, consistently used tools to improve productivity. And I think that would be, I have faith that that's the way AI would play out as well.
Well, there's no question that, as you said, we have had, as a society, many shifts in technology that were accompanied by social and cultural shifts. If I were a developer today, I would be thinking about how do I use these tools in order to be more inventive, more innovative, and more efficient, because that's where the future lies.
Indeed. I mean, I think, again, in that use case, Michael, like if you're a developer, I think all of us who've written code know the frustration of trying to debug your code, right? Or being able to kind of refactor something that you needed to change for any particular reason. These are not value added tasks, right? These are essentially things that slow you down as a developer. So if you have an agent that's able to go in there and run a debugging a program or like a compliance thing and come back to you and say like, hey, here's the things that I found, or here's the things that I fixed, and this is what you need to rethink. I mean, just imagine the amount of productivity you would get out of that. I mean, the general notion, obviously, code is one of the best use cases for large language models because code happens to be a form of language. Is that we will probably produce 10 times more code than we're currently producing. So, what are the use cases for if you're able to produce 10 times more code? Like what can we automate, right? And what can we do better? The tasks that we never envisioned before that we're currently doing because we have access to the internet and things that are online or a mobile phone, and so I think that's the way of the future, right? So that's what I'm excited about.
And on this exact topic, Arsalan Khan comes back and he says, won't these agents replace white-collar jobs also, which white-collar jobs that require some sort of analysis? And he says, are these agents the death of consultants? And let me just inject here that firms like Accenture, for example, are investing literally billions of dollars in retraining their consultants to coexist and to use these technologies. So the issue of replacing white-collar jobs that require analytic skills. What about that one?
If you actually look at some of these consulting firms, I don't know which one, but they actually announced that generative AI was a huge driver for their revenues over the past quarter. So and we see this too. A lot of our companies are partnering very closely with a lot of consulting firms, systems integrators, as they help the kind of the wide swath of enterprises and companies adopt these new technologies. Again, I think, look, when you think about an analyst's task, right, there's a bunch of like, okay, is there really a value to researching, like doing a Google search or whatever it is, and finding out, if you're a financial analyst, essentially trying to look at go and just acquire the financial statements of all the companies that you're researching, or would you rather have generative AI do that for you? So you might actually then really focus on the objective, right? So I think we've got to sort of, again, the capability of AI where it stands today. It's all I can speak to, right? What it can be 5 years in the future, 1,000 days from now, it's hard to speculate, primarily because the platform's changing so fast. I think where it is today, it is a very effective tool to offload, your repetitive and sort of non-value add tasks. I think human reasoning, human judgment, whether it's a marketing campaign, whether it's financial decision, right? You have quantitative investing today, right? I mean, high-speed trading is sort of there. It has not really replaced, financial analysts or, the investment professionals in the marketplace. It has become a tool to provide better data, so better decisions can be made. So ultimately, I think it's about adaptability, in my opinion, of how do you use this tool to unlock new capabilities and new higher level of productivity. That's what I believe in. Again, as things evolve in the future, who knows, right? But I do think that we've seen enough technology cycles where I don't believe AI agents somehow will eliminate a swath of white collar jobs. It will make white collar jobs more simple. It will most certainly make the job of let's say an early stage legal analyst or a financial analyst more interesting, because it's less about, going out there and doing a bunch of research, more about sort of thinking about, the data and coming to judgments or solutions.
We have another question again on this same general topic from Elizabeth Shaw. And what I find very interesting from the questions is this overall concern can we say, about the impact of AI in general and agents in particular on jobs. And Elizabeth Shaw says, what are the potential harms that may come from automating decision making using agentic AI at scale?
You notice one of the things I said about AI agents is trust, right? In order for AI agents to be able to autonomously function, which is the technical definition of an agent, we need to be able to trust these agents. So what does trust mean? Trust is a set of different things, right? Trust is essentially getting the task done right, and not hallucinating or giving you wrong answers very confidently, right? That's one aspect of trust. And so, as models progress, as techniques progress, whether it's, techniques like RAG, or larger context windows, or, chain of thought reasoning, et cetera, you're going to get better, more accurate in terms of how you would how you'd be able to trust these models in terms of their output. But the other aspect of trust that's really important is this notion of is it an optimization function that just is focused primarily on optimizing whatever task gets given to it, or are there some guardrails in terms of how the model actually goes through the process of optimizing the task it's given, right? And you've seen this already widely discussed. Every large model provider has sort of safety responsibility as a top priority. There's even a new company that was started by one of the founders of OpenAI, primarily focused on safety and trust. Government regulations obviously are being actively kind of discussed in terms of how do you define the guardrails, right? Where's the responsibility lie? There's a lot of learnings that we have from previous technology cycles where we are trying to apply them to AI. And it's an active area of debate, right? Clearly, I think government regulators are being thoughtful, trying to understand exactly how AI works and making sure that we don't overregulate it too early in the cycle before we know exactly what it entails. But I would think about trust as the foundational aspect of any AI agent that gets deployed there. And for companies that are developing these AI agents, that's a fundamental aspect. And for you as end users, enterprises looking to leverage AI agents, I think that should be a critical factor of choice as you're making those decisions.
If we go back directly to agents, you've spoken about some of the applications. Can you describe how we create agents, and also maybe some of the companies that are out there who are working on this?
The way we think about agents is effectively the evolution of application. So yet, applications, could be a particular set of tasks that are encapsulated in software. And then there is a workflow associated with that application, right? So you have a system of record. The system of record essentially stores a bunch of data. It could be an ERP, and there's a workflow associated with extracting the data from that. Maybe formatting it in a certain way, creating a chart, or being able to sort of make a set of decisions. Comparing contracts or what have you to initiate a quote to cash kind of workflow, if you will, that sits on top of your ERP. So the way I would think about an AI agent is that an AI agent essentially is the application itself with some of the workflow associated with that application absorbed into the application itself. So you're reinventing the application as an application plus the associated workflow, which again, we talked about could be the repetitive sort of things like extracting data, comparing data and such like, which is now being able to be done by the agent itself, right? So that's a broad way of the way we think about agents. So if you're gonna let's say you're in the process of building an agent, the first step is getting your data in shape, making sure that the relevant data that you have access to, either as an enterprise or as a end user or as a knowledge worker, is accessible through an API. So you're able to use that data to inform the model. as it's executing through its tasks. Going back through to the hierarchy, right? So once you plan the task and break it down into specific subtasks, one of those tasks could be, hey, go get this data, right, and compare it to another piece of data in order for you to make a decision, right? Or get a SKU, get the price point associated with that SKU, get the customer's end customer, figure out what the discount for that customer is, and then spit out a final price, right? That could be a particular task. So that involves essentially going and extracting data, comparing data, using the logic associated with, a particular sort of customer price point, and then providing the output. So you think of these as establish the data, create sort of the modules that you need in order, the logic of what you're trying to execute, right? And then be able to sort of, wrap it around with a user interface that lets you, that's essentially, that becomes your agent. So today you have a variation of these things, in our portfolio, just examples. We're focused on sort of the infrastructure aspect of AI. So companies like Crew AI, which is an open source project that helps you, if you're a knowledge worker, build very simple sort of agentic workflows, as well as for more complex enterprises, be able to kind of take a complex application and break it down into an agentic workflow. It's open source. It's one of the more popular projects out there. Or something like Workato. Now, Workato is an iPaaS platform. So Workato essentially brings together all the applications and the data into one integration into one platform, and then enables you to build applications or automations on top of that using an agentic sort of use case. Another interesting one is Torque. They recently announced sort of a agent for cybersecurity. Like one of the challenges with cybersecurity is you have a ton of data. You're trying to sort through all of that noise to figure out what the appropriate signal is. So you can actually build agents that are, constantly running, being able to evaluate these signals and be able to sort of, as an analyst, as a agent analyst, I suppose, apply the logic of what you're trying to do. More on the sort of the broader industry, you have the full spectrum. I mean, last week, Salesforce announced Agentforce. If you notice, one of the key things they talked about was that reasoning layer that they've created. It'll be interesting to see how that works, and if they've indeed sort of solved reasoning, that'll be fantastic. I call that a captive agent because effectively it's running on the Salesforce ecosystem. And so, some enterprises, large enterprises, are building agents that go across their real estate, which are more sort of, broad-based across different systems of record. Multion is an interesting one. Div Garg, amazing founder, focused on the consumer use case, like a personal assistant, personal agent, if you will. Or Sierra is another interesting one for the customer service side of things. So these are some of the examples. Again, I will sort of caveat all of this by saying we're still in the early phases of this journey towards AI agents. There's no, if you look at the technical definition of autonomously operating, application, we're not quite there yet. There's still a significant amount of human in the loop, and also significant amount of sort of this barrier of trust that one of the audience members talked about, which is an important factor that's still being worked on. So, but we are well on the way to the journey, towards sort of thinking about what an agentic, architecture in an enterprise would look like.
And Arslan Khan comes back again. Arslan asks great questions. And he says, can you talk about the right type of data that needs to be collected in order to implement these agents? He also wants to know, should the agents be transparent on how they came to their conclusions and guidelines on transparency? But again, that's really a kind of separate entire domain. So what about the data issue?
I think just a quick one on transparency. I think most models today will be able to show you what they have actually done, right? In terms of provenance, what data they looked at to come to a particular decision, what specific sort of algorithm or logic that they ran. And so you actually have some of that already today in the models. And again, I'd point to some of the models like Claude's or Anthropic's Artifacts, which is a great sort of construct in terms of being able to outline some of the steps that the model is actually taking in order to execute a task. Now, coming back to data, it's a very important question because I think, as I said earlier, the first step towards any sort of implementation of an AI or an agentic application is your data layer. Now, data layer could be multiple different things. Most sort of frontier models, kind of large models today, are trained on sort of the corpus of data in the internet. I think we can all bet on more TikTok videos coming out or blog posts coming out to continue to kind of feed that mill. But what's becoming more important and actually more interesting in the context of enterprise use cases is the domain-specific data, right? So each of you, I guess, in your enterprises, depending on the kind of vertical that you're in, it could be real estate, it could be construction, could be pharmaceuticals, industrial, et cetera, have a very unique set of data. Right? It could be failure rates, could be records of successful executions, et cetera, which are captive within your organizations, right? Thanks to sort of the big data era over the past 10 years or so, organizations have done a very good job of actually collecting all of this data in a coherent manner. So now we have all of that data, and assuming that this data is accessible, right, through an API or through the integrations, to an iPaaS layer perhaps, you can then use that data in a couple of different ways, right? You could either fine-tune your own model. So, I've talked to CIOs who basically said, hey, this Llama model is amazing. I've got a 7B model that I'm working on, and I'm actually fine-tuning it on a construction data set. So I can better understand sort of, what demand looks like, or what kind of timelines, things that are specific to the construction industry. In some cases, people are using a closed model, but with using RAG, right? Retrieval augmented generation. Effectively, what RAG lets you do is, you're not training the model, you're effectively giving it the appropriate data and context, so it gets you to the right decision without having to train the model and maybe risking the weights leaking back to the model provider, right? So there were various different techniques, starting with sort of creating that data layer and the accessibility of the data layer. You have techniques that, fine-tuning, RAG, embeddings, right? In some cases, you have these like models are coming up with increasingly larger context windows. I think Gemini 1.5 Pro is about 2 million context window, which allows you to put in like a ton of PDF documents if that's what you choose to. So I think you harness the data and you leverage the data in order for you to build and optimize the model to your particular use case. And depending on your sensitivity, you use fine-tuning or some of these other techniques to do so.
Correct me if I'm wrong. The core of it is the LLM, how that LLM is used and prompted. So it's all bound up in the standard LLM stuff that we know and love or hate. And then that is embedded into this broader enterprise application framework that includes security and the ability to scale and so forth. Is that a correct way to look at it?
If you think about your next generation application as an AI agent, right, which effectively is your application logic plus associated workflows absorbed into one entity, that AI agent will consist of multiple different components. They could be multiple different LLMs that be part of this AI agent. You could have an LLM that's doing your user interface. You could have an LLM that's doing your planning. They could be an LLM that's a domain-specific model that's very focused on a particular task, right? It could be a data retrieval task, or it could be a forecasting model that's non-LLM, more a regular kind of old school machine learning model. And you compose all of these together, and that's why I said building an agent is more of an engineering problem than an AI problem, because AI is one of the components. There's a lot of data integration, API integration, lots of glue code logic that you need to kind of connect all these parts in order for it to actually work, right? Now, you may do that, or you may basically go to a company that's, building a vertical agent, or you might use an orchestration framework like a Crew in order to, build these pieces. A Crew lets you kind of define an agent, give it a set of skills, give it a set of tasks, tools, right? And then compose a set of flows, right? In a very logical way to say, here's how you take a task and break it down, right? And I may be pre-announcing this, but, Yohei is coming up with Baby AGI 2, right? Which is, again, an open source model for, tasks, and now he's providing tooling capability to that platform as well. So I think so you think of this as frameworks, data platforms, right? And either you're building one from scratch by yourself, your own AI agent, or you're able to go, acquire like task-specific agents for specific things that you're trying to accomplish.
I heard this story 25 years ago in the transition to object-oriented programming.
AI is a tool. AI is a function, right? Or a subroutine, if you will, if you want to go way back, effectively executing a task, different kind of logic, right? But your application itself, even today, classic application, you have a front end, you have a back end, right? The notion of a full stack that it requires to actually bring an application, to life. Same thing here. It's just some of these components are leveraging a large language model or a generative AI model.
Arsalan comes back again. I love his passion and the thoughtfulness of his questions. They're very insightful. Arsalan says this: as a recovering enterprise business architect, do they have any role in AI? And should these folks report directly to the CEO?
As AI and agentic frameworks advance, I think we have an opportunity to kind of rethink what enterprise application architectures look like, right? There are certain things that obviously are going to be around and it's going to be more and more important. Obviously, the data layer becomes incredibly important, and we're only going to generate more data. And I think that the ability to kind of bring together this concept of an agent, as I said, again, it's an engineering problem, less of an AI problem, right? So an enterprise business architect, depending on how you define that role, could have a very important role in re-architecting, right, what enterprise architecture looks like with these new tools, right, and with these new concepts. So I think again we're sort of in this experimentation, tire kicking stage of AI, and every enterprise or every CIO or every enterprise architect, what they're solved right now is playing with these models and trying to figure out, okay, how can I take what I'm doing and do that 10% better, 20% better, right? So we're on that curve of improvement, if you will, and I expect, and I suspect this is going to continue. So if you are an enterprise systems architect or business architect, it's a great time, right? Get your feet wet and start looking at your existing applications or architectures and figure out, where would an LLM make sense? It could be as simple as can I just wrap an LLM around my existing application to make it much more easier to use, right? In terms of discovery of capabilities and such like.
Can you help technology leaders see through the agentic hype when evaluating these technologies? The hype around agentic AI is just through the roof right now.
Yeah, there's a lot of excitement for sure. And there's a lot of agent washing happening as well. I think marketing decks are very, very quick to adapt to the latest vernacular, if you will. However, as I said, hopefully, like in the conversation we had today, your audience get a better sense of, what is that sort of, if you pick apart an agent, what does it really look like? And what are some of the key capabilities that you would want to inspect it for, right? And it's okay, right, in the sense that we're not I don't think we should withhold this concept of AI agents till we get to the point where everything's autonomous. I think it is a progression, and we're rapidly making a lot of progress, right, on specific aspects of what agentic frameworks end up looking like. And I suspect that there's a lot of value to be derived just in even deploying sort of the kind of solutions that we have today. Look, ultimately, the one thing we have to think about here is that, LLMs are non-deterministic models. So, effectively and we've all experienced that. You put something into ChatGPT and it'll give you an answer. If you prompt it a certain way, it'll give you a different answer. If you prompt it another way, right? So there's a huge amount of work and interesting techniques that architects and engineers, right, as well as analysts need to do in order for you to kind of figure out, how do I take this really powerful tool, right, of a large language model with its associated sort of non-determinism and be able to kind of build a deterministic system around it. And obviously various different techniques to do that, guardrails, right, reflection loops, the chain of thought reasoning, et cetera, in order for you to get to more accuracy. So we're actively progressing that. But again, it's a very, very interesting, powerful tool, has tremendous advantages, has things that's still, work in progress. So, as an engineer, you're trying to figure out, how do you incorporate that? How do you get more productivity and get on that journey, if you will, right? That will hopefully get you to a modern AI-enabled architecture.
I love your comment, building a deterministic application based on a non-deterministic LLM.
We have a history of using these kind of tools to build very deterministic outcomes, right? I mean, again, I was early in the internet era, and most of you obviously may know or may not know that the internet is a statistically multiplexed distributed system, which means that if we're doing this on the internet right now, there's no defined path in order for my information, my packet to get to you. You just launch it at the internet and it finds its way. It's a non-deterministic system, depending on, it's making decisions at every single stage. But however, we have a very deterministic outcome, which is we have the show that's going on right now on the internet with high fidelity and high quality, right? So, just the fact that a system is non-deterministic doesn't necessarily mean that you can't build a deterministic application or get a deterministic outcome. It's really about understanding the system and making sure that you adapt to its capabilities. And as things get better, obviously, you'll need to do less. But yeah, I mean, that's the exciting part of building with frontier technology today.
One last question from Elizabeth Shaw. How do you ensure that agentic AI doesn't go off the rails over time?
There's a lot of things we can do, right? One aspect of thinking about agentic AI is that it's not entirely all AI, right? There's a lot of, deterministic machine learning models. There's a lot of static code. You will have to think deeply about sort of what are the governance and policies that you want to kind of wrap the model, wrap the agent with in order for it to function. So the guardrails that you can provide for output is a very important aspect of the design principles of how you build agents, right? And I think there's, we have sort of policy governance today in a lot of our enterprise applications. In the AI context, I think you're not essentially just taking the LLM's output and directly presenting it to the user. In a consumer use case, yes, right? But in a consumer use case, we all use our judgment, right? So, I was asking one of the large language models, like, hey, how do I reach sort of, somebody who's working in government policy in a particular company, right? And basically said, oh, just send an email to policy@company.com, which is obviously made up, right? But then I look at that and say, like, that doesn't make sense. Are you sure there's something like that, right? And it's, oh, well, then here's a website that you can go to that you may be able to find people in that. So as a consumer, you can afford to, directly interact with the LLM. But as an enterprise, going back to this concept of like deterministic outcomes, particularly if you're making trust-based decisions, it behooves you to basically have a governance policy layer that the output passes through before, that's presented, right? Particularly if you don't have a human in the loop.
And with that, I am afraid we're out of time. We've been talking with Praveen Akkiraju. He is managing director at the VC firm Insight Partners. Praveen, thank you so much for taking time to talk with us today.
Thank you.
And everybody who watched, thank you for your questions. Before you go, subscribe to our newsletter. Go to CXOTalk.com. We have great shows coming up. Subscribe to our YouTube channel. Thanks so much, everybody, and have a great day. We'll see you next time.